And in today's class, what we are going to do is, we are going to decode some of the things that has been there for long enough, but I'm not sure how many of us are convinced or sure about it. If I say area of a triangle, everybody will say half into base into height. Okay? No question asked. Nobody has any doubt about it. This formula is straightforward, as if somebody is asking you your name. Everybody knows it. Okay, understood. How about this? I have a triangle. Let's say this is my base, 5 centimeters, and I have another triangle. Here also, if you see, this is my height. So base is the same between this one and this one. This triangle, let's say this is ABC, and this is D. So there are two triangles, ABC, the right angle triangle, and this triangle BCD. Okay? If you go by this formula, both have the same height. This is the base is same. So the area is same. But why? They don't look to be the same. Yeah? I mean, if I as a teacher tell you that, okay, any triangle you have to find out the area of a triangle, it is always base times height. So whether a triangle is like this, or like this, or like this, they have same area. Difficult to believe, isn't it? Yeah? Okay.
But sir, if it's a scaling triangle, what would you do then?
No, so I did not say scalene, I did not say right angle triangle. I am just saying that the generic formula that we all know, that says area of a triangle is half into base into height. Okay? Now the $1 million question that we have is, if my base and my height are same, Luta, come on. So Moira is not feeling well, so she is joining online.
Oh, okay.
So you can sit down here. If you are feeling hot, you can turn on the AC also. You good? Okay. So right now we are trying to kind of look, Gayatri. So let me quickly do a roll call, and then I'll get everybody puzzled before I start teaching something. Right? So we have Advik, we have Dikshita, we have Gayatri, Suhina, Moira, Sami, Shaurya, Vasundhara and Arav. Okay? So my first goal, and here in the classroom I have Arya here. So my goal is to get you all confused first. I'll create confusion first, and then we'll try solving it. So here's the thing. Source of the confusion is this formula for area of a triangle. If I ask anybody with your eyes blindfolded, say, okay, what is the area formula for area of triangle? You'll say half into base into height. Everybody, right? Area of a triangle equals to half into base times height. Everybody okay with that? No questions? This is the formula that I've written. That means for me to, or for us, for all of us, to find out the area of a triangle, we only need to find out the base and the height of the triangle. Now let's look at this. Let's say this is my base. This is one right angle triangle. Let's give it a name, A, B and C. I want to make your life as complicated as possible. That's the goal. So now this is the base and this is the right angle triangle. What I'm doing is, let's say, what I did was, I have drawn a line parallel to this line. Okay, this line's parallel line is this one. Meaning, my height here and my height here will be the same. Let's say this is K. This height DK and CB will be the same. Yeah. I take third point here.
That's here.
That is here. Okay. All right. Go slow. Don't rush because it might be slippery. And I took a third point, and I have joined these 2 points. Now let's say this is F. So first triangle is ABC. My second triangle is ABD, and my third triangle is ABF. Everybody is okay with the drawing? Yeah? Okay.
Yes, sir.
Shaurya, are you okay? Yeah, okay. So, now if somebody says find out the area of the triangle, all the 3 triangles, you will say yeah, the area of any triangle is half into base into height. This is the base which is common for this triangle and this triangle also. So all the 3 triangles half into base is this one AB, and height is also the same. Here this height and here this height, and if you draw perpendicular, this height is also the same. It will be same as this BC. Yeah. See, again I might be taking you guys back to the basics. If I have 2 parallel lines, the perpendicular distance between the 2 lines remain the same. They neither reduce nor increase. Yes. So that's what I have done here. I made this line parallel to this line so that if I pick any point on this height remains the same. So now what you are seeing is this right angle triangle, this complicated ABD, second triangle, and this third even more distorted triangle, which is looking more funny than looking like a triangle, ABF. And if I just go by the basic formula, half into base into height, all the 3 triangles have same area. Yeah? Gayatri, Shaurya, Ayahi, make sense? So as per the formula, these 3 triangles are supposed to have the same area. Yeah? Adri, Karav, do you guys agree? Formula wise. Yeah? So, it doesn't look convincing though. I mean, if somebody forces me to memorize the formula and apply it, I'll apply it, but it doesn't look convincing. We are trying to convince ourselves. We are trying to prove this thing and say that area of a triangle is always half into base into height regardless of, in all circumstances. Okay? Meaning, if I have, let's say this AB, I am making this as a, let's say, C. This is my right angle triangle. This triangle's area is same as this triangle's area. That's what we are trying to prove. Yeah? Meaning area of triangle ABC is equal to area of triangle DAB. That is what we are trying to prove. If these 2 are proved, then I can randomly pick any point here and say, okay, fine, now I can generalize and say, yeah, any triangle's area is half into base into height. Are we all on the same page with respect to the problem statement? That's my first question to you guys. Yeah? Hi, Rihan. So, for all the kids who have joined just now, our goal is to find out that a mysterious problem that was told to us when, I mean, not us, I will exclude myself because my generation is much more ancient than yours. So I'll not put myself in the same boat as you guys. So all of you were told forcefully to believe that area of a triangle is half into base into height. And only thing that you saw happening was that if I have a rectangle, then the area is length into width. Length into width. This is understandable. Yeah? You are saying that even if I join the two diagonals, then I see that my rectangle splits into two parts, right? And my area of this right angle triangle, I can understand, okay, if I count this as base and this as a height, my area will be equal to half into base into height only for right angle triangle. Yeah? This part is okay, right? Problem is more when I am saying, okay, you take any triangle, even if it's not a right angle triangle, take the base and height, that is your area. And you guys are not agreeing to this unless I prove it. Yeah? Okay, I will see, I'm not convinced if whatever I am telling you guys are following me or not. So can somebody tell me the story? What we are trying, what is the understanding, what is the problem statement, and what is that we are trying to find out? Can somebody narrate that story for me? Yeah, Arab, go ahead. Huh? Okay. Anybody who can narrate the story. I want to put the entire energy and focus on making sure that we are very, very clear about the problem statement first before we try solving it. You want to give it a shot? No? My kids are not telling me the story. I love stories. And I feel very comfortable when you guys explain the story. Okay? That makes it easy for me to relate. Okay. So let me break it down. Arihan, you joined a little late today. So all the kids who joined a little late, I would request you all to pay attention and make sure that you are very clear about the problem statement first before we try solving it. Yeah? You all know that area of triangle is half into base into height. No problem so far. This is a formula that we have memorized because teacher asked, daddy asked, mommy asked, neighbors asked, friends asked. Okay? So now we have memorized it. Now comes a teacher with less hair with glasses who is saying, okay, this is a formula and this formula is right, but I know that, okay, if I have a right angle triangle, then I can think of the area of this right angle triangle is half into base, meaning this height and this height, into height. Okay? Because when I think about it a little bit in depth, I see that, okay, this. When I extend these two lines, it becomes a rectangle, and this area of this one is half of this one. Yeah? So, if the area of a rectangle is length into width or base into height, I can say, okay, fine, this will be half the area of this rectangle. Okay? So that's why this is half into base into height. Yeah? So right angle is okay. Looks reasonably okay. But am I saying that my area of a let's look at this. With the right angle I am fine. With the right angle I am convinced that, okay, area of this triangle is half into base, this is my base, into this height. With the right angle I am okay. But are you saying that if I pick this point here on this parallel line and join these two, where my base is the same, but this area of this triangle, let's say if I give AB as the base, C as ABC is one triangle and this ABD is another triangle, are we saying that if my base is the same and the height is the same, meaning height is what? This distance. So this distance and this distance are anyway same because these two are parallel lines. So are we saying that this triangle's area, ACB's area is same as ADB's area? That's what we are trying to find out. Yeah? Because both the triangles have same base and their height is also same, whether it's a right angle triangle or a different triangle, different looking triangle. Both have same height. So my area will be same. But why? How? Is that too much to think? Vasundhara, what is your reading, beta? Tell me what we are trying to solve. Or sorry, or Gayatri, anybody. Are we clear about what we are trying to solve? Yeah? So let's solve now. Enough to get you guys tired and frustrated with my repeated question over and over again. Yeah? I wish you guys had a better teacher. This is the base. Let's draw a line parallel to this. Okay? And I pick a point on this line such that I have a right angle triangle. Okay? A, B and C. Let's say this is height H and this is the base. I will call it B, small b. Area of this right angle triangle is area of triangle ABC is equal to half into B into H. This part is okay, right? I am picking up another point here. Let's say this is D. And I will join A with D and join D with B. Now I have another triangle A, B, D. I want to find out the area of this guy. And I don't want to say half into base into this height is same. I don't want to say that. Otherwise I am forcefully convincing everybody here. I only know that if I have a right angle triangle, then I am convinced that okay, half into base into height. Okay? So let me do one thing. Let me break this triangle into two right angle triangles. What did I do? I had dropped a perpendicular from here to, from this vertices to line AB, the base, and let's say this is point K. So if I have to find out the area of the big triangle ABD, this will be equal to area of triangle, this one. My area of this ABD will be the area of the green triangle and the area of the blue triangle. Yeah? Is that okay? Yeah? So the green triangle is triangle A, K, D. The green one is AKD, this is point K where it's dropping perpendicular. So this becomes a right angle triangle, this becomes a right angle triangle. Yeah? Plus area of triangle, this one, the blue one. So this is green triangle. So let me make this triangle look truly green. Okay? And this is the blue triangle. So let me make it look really blue. Area of blue triangle, which is the blue triangle, is BKD. So far I have done nothing fancy, okay? We are just trying to prove that if these two triangles have the same base and same height, their area will be same. That is what we are trying to prove. But by looking at the picture, it doesn't look convincing. So we are trying to mathematically prove that. Okay. So we took this right angle triangle, and for right angle triangle we are convinced that okay, it is half of the rectangle. So this is half into base into height. This formula we are clear about. This triangle ABD, we don't know if half into base into height is the right formula for this guy or not. Yeah. So what did we do? We took this triangle ABD and dropped the perpendicular from D to B, so that we can split this into two right angle triangles. Because the only thing that we know and we are convinced about is any right angle triangle, the area is base into height. Okay? We are trying to extrapolate that and see if we can apply the same formula for this triangle or not. So we know that okay, this triangle ABD is split into two right angle triangles. The green triangle, which is ADK or AKD, and the blue triangle BKD. Is that, you are feeling very hot, Beta? Shall I turn on the AC? No? Sure? Yeah. Okay. So if we find out this blue triangle's area and this green triangle's area and sum it up and see what is the area coming for this guy, then we'll see if this area is same as this guy or not. Okay? Now let's look at this triangle, the green one, AKD. This is right angle triangle. For right angle triangle we have no problem. We know that the area of triangle AKD is half into base into height. Half into this base. This base is what? A into K times the height. This K into D. And this height is same as this height. Correct? So I will say H. Sammy, Suhina, are you guys okay?
Yes, sir.
Okay.
Yes, sir.
Okay. So what I have done is I have taken this triangle and have dropped a perpendicular from here to here, so that I could split that into two right angle triangles, and we are trying to find out the area of this right angle triangle, this right angle triangle. We'll add them together to find the area of the bigger triangle and see what that turns out to be. So when I look at the green triangle, the area, this is a right angle triangle, half into base into height. Base is AK is the height base, and height is DK, which is same as this one because these two lines are parallel. And between two parallel lines, the perpendicular distance between the two parallel lines remains the same. So that is how this distance and this distance are same. Yeah? Yeah? So now you guys will be able to relate. I have been bothering you guys about the property of the shapes, right? I said if I have two parallel lines, these are like railway tracks. They never meet. If they meet, train flips. Railway accident, which we don't like. So the parallel lines has a very unique property that the distance between the parallel lines remain the same. If it ever changes, meaning the distance between them increases, it will not be qualified to be called a parallel line. Okay? Meaning, if these two lines are parallel, then this distance and this distance will remain the same, because we purposefully have drawn a parallel line. Yeah? So now, this green triangle's area is half into AK into height. Now the blue triangle, BKD, my name B and K, Birendra Kumar, and then D. Whose name starts with D? Oh, Dikshita. Okay. Welcome to the gang. So BKD, the blue triangle, this area is again, this is a right angle triangle again, and we are convinced that okay, for right angle triangle, half into base into height. The base is this one, K into B. K into K, not K into B, it's KB, this distance, into height. Again the same height. So it is H. Now if you look at it, what is common? Half and H is common in both of them. So half into H is common. If you take it out, then you are left with AK plus KB. Look at this, AK plus KB. What is that? AB, which is nothing but the base. What it became? Half into H into B. AK plus KB is AB, which is the distance B. So area of this triangle, which is sum of this triangle's area and this triangle's area, became half into B into H. This is B and this is H. See, for this right angle triangle, we knew that area of this right angle triangle is half into base into height. But even for this guy, it turned out to be the same. That is not fair. Or it's looking fair. I know there will be some questions, and it's okay to have questions. Yes, Arav.
So can we convert triangle ACB and put that two times and intersect it and put ADB and put two of those to make a full square?
Where are we going?
Then we can intersect the shapes and find the full area.
No, my question was different. We just went to a water park to play with splash pads. So I'm just asking, did you guys enjoy that splash pad? We'll talk about the zoo later. On a serious note, what I'm asking is, let's not overthink, okay? Thinking is a very good thing. Trust me, I have a lot of regard for that, and that's why I keep saying this. That if you are trying to learn, if you are trying to solve the problem, read the problem and analyze, meaning think. But think, not overthink. Why I'm stopping you here is, my question is very simple. We can learn, we have enough time with us, we'll learn a lot of things. No denying that. My question is simple here. We were trying to find out that area of a right angle triangle, we know half into base into height. If my height is the same and base is same, are we saying that this triangle's area will be same as this triangle's area? Optically it doesn't look convincing. That is why we tried proving it, saying okay fine. What will we do? Okay fine, these 2 points. Let's drop a perpendicular from here to here so that we can split this into 2 right angle triangles. Because the only thing that I remember, or we all remember as a group, is that area for right angle triangle we are convinced that okay, this is half into base into height. If anybody in the class is not convinced, I will prove it again. But area for right angle triangle is half into base into height. So since we knew that, we dropped a perpendicular from here to here and we split this whole triangle into 2 right angle triangles. We are looking at the area of this right angle triangle, area of this right angle triangle, adding them together, and we apparently got the area of this triangle is half into base into height, which is matching with the area of this triangle which has the same base and same height. So right angle triangle's area and any triangle's area can be derived as half into base into height. That was my question. Now I want to know if you have any doubt about that before I take you guys further on this one. Yes, Dikshita.
Like when we
Unmute yourself.
when we multiply a half AK times H, instead of H, are we supposed to like put D?
AK is the base for this tiny right angle triangle. So this is AK. I don't know what is the length, but I know that AK is part of this whole distance AB, which is total B. Okay. So I put I'm not multiplying this. This AK is the length or the name of the side. It starts from A and goes on till K, which is the base of this green right angle triangle. Okay. I'm not
Then
multiplying. Yeah. Sorry. Go ahead.
Then
Vika.
what's the like the D on top?
D is, so this D is my, so I had a right angle triangle, okay? This was my right angle triangle ABC. Okay? What I did was, I'm trying to find out that if my base is the same and height is the same, will the area be the same half into base into height? See, look at this triangle and this triangle. Are they looking exactly the same area wise? That's what we are trying to prove. So I said, okay, on this parallel line which cuts or crosses this point C, I picked up a point D which doesn't look like a right angle triangle. This one is right angle triangle. ABC is a right angle triangle, but ABD is not. So I picked up a point which makes another triangle ABD that you see here, and I'm trying to find out the area of this triangle, which is not a right angle triangle. So since only thing that we remember or know is how to find out the area of a right angle triangle, so I have drawn the perpendicular from here to here at a point K. I'm saying for us to find out the area of this triangle, we have to find out the area of this blue portion, blue right angle triangle AKD, and the green right angle triangle BKD, and we will add them together because it's a compound shape made of two right angle triangles. Once we add the area of these two triangles, that will give me the total area of the triangle ABD, which is having the same base as the right angle triangle and same height as that. To generalize our formula. Yeah? Yes, Advik.
Can you repeat that again? Like I got confused.
Okay, that's fine. Confusion is a good source of information. If somebody says I'm confused, that's a very good sign. It means that we are trying to learn something. We are trying to break our head with something. Not with a scar, but with a lot of mental digging of the problem. Yes, Beta. So you don't have to be shy, Beta. You could have asked me for that. See, and you can come to this table so that you get straight. Yeah? Okay. So now let me repeat the whole thing. Is everybody with me? Shaurya, Gayatri, everybody, right? Some of you are brave enough to say I'm confused, and I love that. Okay? I love confusion. That's why I was saying I want to get you guys confused. Okay, so we know that area of triangle is half into base into height. Yeah, this is a formula that we all know. And if I absorb this formula on its face value, what it means is, if I have to find out the area of any triangle, it is half into base into height. Meaning, if this is my base, and this is my height. Okay? Half into base into height. This is for right angle triangle. Okay? If I take this, but this is right angle triangle part we have seen. Now we are saying, okay, if I have the same base and same height, are we saying that? So if I go by this formula, as per this formula, if this is base, let's say this is 5 centimeter, this is also 5 centimeter. This height is, let's say 8 centimeter. And this height, meaning from here to here, this is also 8 centimeter. As per this formula, area of this right angle triangle is same as area of this triangle, which is not a right angle triangle. And we are trying to find out why. How? Is that an okay problem definition, Advik? Yeah? Suhina, Sami, everybody? Myra, Vasundhara?
Can you repeat the process, please?
So I'm going to explain everything better. The thing is, we know that area of any triangle is half into base into height. So if I have two triangles which have same base and same height, their area will match. Yeah, as per the formula.
Yeah.
Between these two triangles, my base is same. This one is 5 centimeter, this is 5 centimeter. This is a right angle triangle, and this is not. But here the base is 5 centimeter, here also the base is 5 centimeter. And the height is also 8 centimeter for this guy and this guy both. Both have matching height also. If I go by the formula, This triangle's area and this triangle's area are same.
Okay.
But how? Why should we be convinced that area of a triangle is always base times height? Half into base times height.
Half times base times height.
Yeah, half times base times height. Regardless of the type of the triangle. Yeah?
Yeah.
Advik, are you okay with the problem statement? Shaurya, are you okay with the problem statement? Arihan, are you clear about the problem statement for now? Okay. So, in practical reality, we are saying that if I have one base, AB, and I have a right angle triangle ABC. This is matching with this guy. Some base, some height. Let's say this is height and this is base. And to recreate this whole problem, I am saying, okay, fine. I will draw a line parallel to this base AB and pick a point D. What do you see between the triangle ABC, the right angle triangle, and the new triangle that I have tried to create ABD? Both have same base and same height. Yeah? So as per this formula, both should have same area. Yeah? Gayatri, are you with me, Vita? So as per this formula, if the formula is to be believed, both should have the same area. Let's find out the area of first triangle. Area of triangle ABC. This is a right angle triangle where we have all agreed, we have seen, we have believed that the area of a right angle triangle is fine. We don't mind. This is half into base into height. If this is base and this is height, it is half into base into height, because if I visualize this, it is half of the rectangle with the length as this and width as this. So half into base into height. It's half of the area of a rectangle. Right? So that is how area of a right angle triangle is half into base into height. Into height. So the right angle triangle ABC, this one. Let me do one thing. Let me try finding out something interesting for you guys. The original triangle, the right angle triangle, the one in red. This is 90 degree. One in red. Red and black together have made it look little like grey, but I will still keep calling it red. Okay? The area of the red triangle. See, red and black has made it grey. Yeah. Area of the red triangle is half into base into height. This part is okay. Now, now we are saying that, okay, the triangle, let's say, let me make this, I want to do a better job with the color coding. So this green triangle ABC, sorry, ABD, area of triangle ABD. We have to find out. I don't want to believe that this is half into base into height. I don't want to believe that. Okay? I want to derive that. Yeah? So Inas, are you with me?
Yes, sir.
So far, now I'm getting very stubborn. as a teacher, I want to get very stubborn and say that, okay, I only know that area of my right angle triangle is half into base into height. Everything else I don't believe. Don't tell me that, okay, this is a generic formula that you can apply for any triangle. Okay? So I'm getting very stubborn, strong-headed, very vocal about the fact that I don't want to believe that this triangle ABD's area is half into base into height. Okay? I don't want to believe that. Because I want to believe only one thing, that is area of a right angle triangle is half into base into height. Since I am getting very picky about the formula and I want to only believe one, that is right angle triangle, so I am converting this triangle ABD into a right angle triangle now. What I did was I dropped a perpendicular from D onto this line and I split this into two right angle triangles. One is triangle ADK and another triangle BKD. Yeah? Shaurya, Sami, Suhina. I have not done anything, okay? Now your teacher is kind of forgetting everything due to age. He remembers only one thing, that is area of a right angle triangle is half into base into height. Anything that you give me which is not a right angle triangle, I will say, okay, I will derive. I don't want to use the generic formula. So I had this triangle which had the same base and same height. I am saying no. I don't want to believe that this is the same area. Instead, I will break this into right angle triangle. So what I did was I dropped a perpendicular from here to the opposite line so that I could split this into two triangles, or two right angle triangles, one in green and other one probably black. So I have a green triangle ABK. So green triangle will look green and a black triangle BKD. So this is black triangle. So basically I have to find out the area of this triangle and I don't want to treat this as any generic formula. I said, okay, fine. Let me drop a perpendicular from here to here so that I could split this into two right angle triangles. One is the green one, AKD, and other is the black one, which is BKD. Okay? So if I find out the area of this triangle and add them together, I will get the area of this triangle, and then I will compare that with the area of this triangle to see if this formula is genuine enough. Advik, is that clear now? Up to so far? So again, this triangle is a right angle triangle for which half into base into height. For this triangle, I don't know what is the area, so I'm just trying to find it out. And the similarity between this triangle and this triangle is both have the same base and the same height. But I don't want to believe this formula. I want to derive it. Okay? So that's why we took this triangle, dropped a perpendicular, split this into two, and I'm trying to find out the area of both of them, add them together and see what happens. Is that okay, Advik, so far? Shaurya, Vasundhara, anybody? Gayatri? Everybody clear, right? Are you clear? Okay. So I have this green triangle. I'll have to find out the area of the green triangle and find out the area of the black triangle. Area of the green triangle, ADK. ADK. This is a right angle triangle. What is the area? Half into base into height. Half into base. Base is by this one. AK. Starts from A, goes till K, so I am giving it a name AK. In base into height. This height is same as this one. Again, see, these are parallel lines. The distance between the parallel lines remains the same. So I will give the same height, value of height as H. This height and this height is same. plus, so area of this green triangle is half into base into this height, which is same as h. So half into AK into height. Now area of this triangle is half into this base, which is BK, into height. Height is same, h. So if you look at this one, area of this triangle is half into AK into h, area of this triangle is half into BK into h. So if you add these two areas, what do you see common? Half and h is common in both of them. Half into h is common between both of them. What we are left with here? AK plus BK. AK is what? AK is here, BK is here. When you AK plus BK will give you what? This whole distance, which is nothing but B. So this will become half into this B into H. Half into base into height. Even this green triangle has same area. Area of this triangle, which is not a right angle triangle, but the area of that became half into base into height of A, B and D. Is it looking convincing now?
Yes, sir.
Yep. Advik, are you clear now? Advik, where did you go? Okay, you're here. Be brave to say, yes, I'm clear. You were very brave to say, I have a confusion, and I was very happy about it. Okay, so from whatever circus, drama, juggling, gymnastic, whatever I did for last 15 minutes, one thing became very clear, that area of any triangle is equal to half into base into height. Why? Because you guys saw that if this is the base and this is the right angle triangle, and you picked a point here, you saw this area is same as this area. So then you can extend that, okay, I will pick another point here. Keep the base same, keep the height same, your area will be the same. Now you can generalize it. If you still want to prove for this triangle, you can always do that. It will be a little different. It will be this triangle, area of this triangle, you will have to subtract from the area of this triangle and you will eventually get the same thing. Okay? So let's not worry about that part. But with whatever we have done so far, at least we are clear that area of any triangle is half into base into height, and if we extend that information, then you can say that, okay, I have one base A and B, and if I draw line parallel to this one, any point you pick up, this triangle's area, this triangle's area, this triangle's area, this triangle's area will all be the same, because we saw that area of a triangle is always base times height. If your height remains the same, no matter how funky, how stupid the triangle looks, your area will be half times base times height. Yeah? Or you can also think or generalize. Tomorrow if somebody, very intelligent, or somebody is claiming to be very intelligent in your school and says, okay, you can pretend to be, smarter than your friends. Say, okay, fine, see, I'll tell you one magic trick. Take a base, draw a parallel line, pick up any point, draw a triangle, draw a triangle, draw a triangle, draw a triangle, draw a triangle. Every triangle has the same area because they have a common base and the height is the same. Yeah? Make sense? Sarya, Suhina, Vasundhara, Hiranya joined a little late. But is that making sense? Advik, Arav, Myra, Aryahi. You look tired, but all okay? Okay. I know Myra is not in the classroom to bother you. Okay. So, in tomorrow's class, we will break our head. And I'm hoping that whatever we did just now, you'll be able to relate to that to build a confidence. Yes, Sami, you're saying something, Beta?
No, sir, I just asked him.
Okay. So, whatever we did today, the idea was to make sure or to equip ourselves to be confident about the fact that area of a triangle is not half into base times height just because we read that in the class. Because as you guys keep on growing, you will see that everything that we have learned as a formula, now our focus will change from learning the formula to deriving the formula, so that those concepts becomes completely yours. Okay? Tomorrow if you forget the formula, you should be able to derive it by yourself. I mean, I'm not saying that you will have a lot of time during the exam to solve it, but math, you will forget me, you will forget school, you will forget your school teachers. What you will not forget is the concepts that you learn now. Okay? So, always focus on making sure that whatever you learn, you carry that as a concept with you so that you are able to derive, you are able to explain, you are able to talk about it, you are able to build story out of it. Arihan, Saurya, is that making sense? Yeah? Okay. Hiranya, you joined a little late, beta, but I have a task for you, and that task is just to watch the video of the class and come back to me if there is something that is not clear, okay? Yeah? Hiranya, not saying anything? Hiranya dropped off. She talks less, unlike me. I talk a lot, right? What to do? Imagine a teacher doesn't talk. Imagine a teacher coming to the class and not talking. What will happen? Yeah. And more importantly, as a teacher, I always feel that the teacher is supposed to have more passion for the subject than the student. If I love the subject, I'll make you guys fall in love with math. If I don't love the subject myself, there are no ways I'll make you believe that math is a subject that you should have a strong liking for. Yeah? Alright. That is the gyan or the free tips that I keep on giving you guys. Because tips have become non-taxable now. Okay. Alright, let's come to the serious point. The next thing that, see, here, if I ask everybody, how do you find the area of a rectangle? Everybody in the world knows, and I'm not going to prove that. It's fairly straightforward. But, if I say what is the area of a parallelogram, if let's say this is my rectangle ABCD, and I'm drawing a parallelogram with the same base. Now this is BCEF. What is the area of a parallelogram? Base times height. This is your base and the height, the distance between the two parallel lines. Yeah? Yes, Arav.
I think you meant the area of a parallelogram is base 1 plus base 2 times height.
Base 1 plus base 2 times height. Now, that is trapezoid. Half into A plus B times height. Anyway, see again, I might be saying the formula itself wrong because I have no respect for my own memory, okay? I don't trust my memory. I respect my concept, and that is what I'm trying to inject in each one of you, okay? So, coming back to this one, area of a parallelogram is base times height, or base times the distance between the two parallel lines, okay? Base times the height. And whatever I'm saying, see, area of a rectangle is length times width, or this is width. If I call this as a base and I call this a height, same. But how come this area of this rectangle has the same formula as area of this parallelogram, base times height, the same value? We will try proving that applying the concepts of congruence that we have learned. Okay, we'll use the concept of congruence to find out area of a parallelogram. So whatever I told you about the formula for area of parallelogram, you can forget it completely, because I don't think I said whatever I said is right or not. I don't remember that. We'll instead derive it tomorrow, and then post that we can take it forward, because you'll have not only the formula from me but also the proof from me. Yeah? Is that making sense? So, any formula that I tell you, I have not written a single book on math. So, I have no authority to tell you guys a formula unless I explain you how did that formula come into existence. So, I have to tell you that as a student, so that you can trust me as a teacher. Okay? Alright. All that was theory for today. We just learned one thing, that is area of a triangle is half into base into height, and regardless of what kind of triangle we are talking about, the formula will remain the same. Tomorrow we will learn how to derive the formula for parallelogram, and we will apply the theorem of congruence for doing that, because that is going to help us. Now, before we leave for the day, any triangle you talk about, area of the triangle will be half into base into height. So if it's not a right angle triangle, you will drop a perpendicular to find out the height. If you take this as a base, then you have to drop a perpendicular and find out this height. If you take this as a base, you have to drop a perpendicular and take this base and this height. So remember that there is no side of a triangle given a name of base. It's the way you look at it. Okay? Like this eraser, dry eraser, right? I can keep it like this. This is my base. Now if I flipped it, this is my base. If I keep it like this, this is my base. Likewise, if you have a triangle, you can look at it from here, climb up on this table and look at it from here, bring the table here, climb up on the table and look at it from here. When you are looking at it from here, this is your base, this will be your height. When you are looking at it from the bottom, this is your base and this will be your height. When you climb up the table and look at it from there, this is your base and this will be your height. So you have to always find out which one you are considering as a base, and the opposite vertex, from there what is the height. That's how you have to look at it. So if you are talking about this triangle, let's say this triangle, you can find the area of this triangle in three different ways. You take this base and find out this height. You take this base, find out this height. You take this base, find out this height. Yeah? So there is no side in a triangle given a name base. It is about how you make or visualize that base. Whichever side you call as a base, look at the opposite vertex and find out the height from there to the base. Yeah? Alright? So with that much of a loaded discussion, I will let you guys go, relax a little bit, stress out, take a deep breath, forget about your teacher for next half an hour, 45 minutes at least. I'll come back to bother you guys tomorrow same time. See, who disappears first? That is Myra always. As soon as we say we are done, the first person who leaves is Myra, who is my own daughter. She is in a hurry to leave the class immediately. Alright, have fun.
Bye, sir.
Bye bye, bye bye,
Bye, sir.
bye bye.